Yes, as Matt just said, I'll be introduce a little bit of what semantic merge can do together with ReSharper, right? Basically, the concept here, the main idea is to create some refactors with ReSharper and then show how they can be merged using semantic merge, which is the main goal of the system. Well, the agenda is basically just 3 points, right? I'll just start introducing a little bit about what semantic merge is. Then we'll just jump into different cases. I have several cases ready to be just showing some of the scenarios that semantic is able to go through, and then of course we'll have a questions and answers section, right? But as Matt said, feel free to ask questions as we proceed. So, well, a little bit about what semantic merge is, in case you still don't know, and I guess most of you will, just reading out the name. It's a refactor aware and programming language aware merge and diff tool. What does it mean? Basically, it's slightly different than all the other tools doing merging and diffing, because it's basically able to do the merge at the structure level and not the test block level. So the main point, I mean, what it means is, first, it parses the code. This is how it works, actually. It first parses the code, then creates an intermediate representation of this code, knowing that a method is a method, that a property is a property, that a class is a class, what a namespace is, how they are related to each other. And then it calculates the differences between the different trees, and then looks for conflict between them. What we had in mind when we came up with semantic merge from the very beginning was, okay, try to enable what we call string refactoring, right? I mean, do whatever refactor you need to, and we're able to merge it. We're still working on that, right? It's not that every possible refactor can be merged, but we're moving forward. And it's important to highlight that it's a three-way merge tool. Basically, it uses two contributors plus the base. And I'll just spend a minute explaining that. Well, just a little bit of a reminder, right? Suppose you have a merge, like the one here, couple of branches. You want to merge chain set or commit number 6 into number 7. Okay, any modern version control, if you're using Git or Mercurial or own Plastic also, okay, it will be able to find that there's an ancestor for the merge. And in this case, in this particular case, will be number 1, right? So what the version control system will do is it will send to the external merge tool 3 files for each. I mean, 3 versions, 3 revisions of the same file for every file to be merged. And this is how Semantic works. So Semantic can basically work with any version control system that supports 3-way merge. I mean, it can work with Git, it can work with Mercurial, it can work with Perforce, with TFS, with ClearCase. Well, really a bunch of systems out there. It's more, I mean, it's easier to just say which are not supported and the ones that are supported. At the end of the day, is just actually replacing the merge tool you're using, like WinMerge or Araxis or any other of these great text-based tools, but this one that is semantic, right? So it's based on parsing the source code. Well, there's documentation on how to set it up and so on. So let's jump into the code, right? The first thing I'm going to do, the first case I'm going to talk about, it's a very typical case that shows a little bit of the power of semantic. Suppose you have 2 classes, the one on the left, the one on the right, and then 2 developers working in parallel simply decide to add the same method into different locations. This is probably not something that is going to happen on a daily basis, but it's something that can happen when you're merging code and people is working on separate branches or even on a trunk branch, but working in parallel on the same files. Okay, what will happen when you merge this? It's not a very difficult case anyway, but what happens when you merge this? Well, first, let's think what happens if you use a conventional, and by conventional I mean a text-based 3-way merge tool. Well, basically, there are no conflicts, and it would just put the 2 methods together. Why? Because it simply finds 2 blocks of text that have to be added on different positions. So you set your tool to resolve the merges as automatic as possible. There won't be any conflicts, and you will just get the 2 methods on the resulting file, which is not what you would like to get, right? Okay, I'm going to show you actually the the case in action. This is basically the code I'll be using for the example. It's very simple. It's not even real code. I mean, the structure is okay, but the code is just whether comments or just fake code. I just want to focus on the structures, and so keep it very, very short. So what I'm going to do is basically I'm going to simulate two developers working in parallel on this code, right? So the first thing I'm going to do is to create a branch and switch to it. Well, I'm using Plastic SEM because it's the version control I'm most used to for obvious reasons, but obviously you could do this with any other version control, Git, Mercurial, whatever, right? So, okay, I'm on a branch, and the first thing I'm going to do is I'm going to create a new method, internal string get host by name, string host, and just a very simple body. You don't expect any fancy code here, just return string empty. Something very, very simple. In fact, what I'm going to do is I'll just copy this code and paste it on a different branch on a different location, right? So this is all I'm going to do. So I will just go and check in my changes. First method added, and now I will just go and do exactly the same on a different branch. I'll start from the same one. I have a bunch of branches here because I was testing the scenarios before, of course. Okay, so I will just call it developer B, which is not a good name for a branch anyway, but just for the sake of simplicity. And what I'm going to do now is just go and add exactly the same methods at the bottom of the file. I save, I check in, second checking on a different branch. So basically the same method is being added twice in parallel. And now what I'm going to do is just merge the two branches together. So that's exactly what I'm going to do. I'm going to merge this branch into this other branch. Let's go. If I merge one branch into the other, well, I get the merge window. I run the merge, and here it goes. Now you're going to see Semantic in action. Okay, here we are. This is basically SemanticMerge, and you can see the graphical user interface of Semantic, which is slightly different from mostly the other three-way merge tool you're probably used to, right? Well, what Semantic's saying here is, okay, you have the same method, get host by name, added twice. That's why it says added on the left, added on the right, means one contributor, the other contributor, and it's saying it's automatic. If we go to the result file, click on view on result, it's saying, okay, I just added it on one of the locations. It knows it's just, the method that can be placed on the top or just on the bottom of the file, no problems there. So it's just deciding one of the two. You can later on just go and rearrange the file and move the method locations, right? So that's not a big deal. And it's just saying it's automatic because I know it's exactly the same method because it has the same signature, it has the same content, so there's no conflict here. If we look at it visually, we'll just zoom it out a little bit. You see exactly the scenario, how the class was, the method added in one contributor, the method added in the other contributor. If I just click with control on both, I can also div the code, and in this case, it's telling me, hey, they are identical. So there's really nothing to do. It's a very simple case, but it's already showing a little bit of what Semantic can do. Because let me just run, well, in Semantic, we always have an option to run the text merge. So you can set up any text-based merge tool you want. We include one by default on the package, but you can set up KDiff3, WinMerge, or Access, whatever. I'm going to run it just to show you how the merge looks like. Well, no conflicts, actually automatic, as we said before, but the methods added twice, which will be a bit of an issue on a real scenario. Of course, not the end of the world here. It will be easy to catch this one, but if you are merging several, dozens of files, and this just goes automatic, well, Semantic will just catch it, right? Okay, this is like the first case. I'll just finish this example, and I'll go back to the presentation and go to case number one. Well, at the end of the day, as I was just saying, Semantic knows about the method. So it knows it's a method. It knows the two other methods are actually the same. So it just keeps one of them. Okay, let's go to the second one, which is one of my favorites today. And I'll start using ReSharper here because the first test scenario was so simple that I didn't use it. So suppose we are on the following scenario. You're working, well, this is very typical for some open source projects where you're using C# and then one of the contributors uses ReSharper, and then he has a great idea of just clean up the code before submitting it, which is okay because ReSharper does a good job there, but then the merge is typically a nightmare, right? Okay, let me show you something. Well, what I'm going to do is I have a custom code cleanup set up in my ReSharper. So basically, I'll be doing just something very simple. I will just be reordering the time members. In fact, I just set up my time members layout in a custom way. So I sort the methods first by access order, public, then internal, then protected, and private, and also by name. So when I do that to my code, you'll see something like this. Basically, what you are going to see here is that, well, all the methods are reordered. What I'm going to do in my example is that in one of the developers is going to clean up the code, just right-click and clean up the code, and the other one is going to modify a method. Then we're going to merge. As you will see, well, a regular merge tool will have a bit of a problem doing that. Okay, let's go back to the code. I will open my case number 2. I have a directory here with all the cases. So here we go. Here we go. Okay, so what I'm going to do, as I did before, I start on a clean scenario, and I'm going to create a couple of branches. So I'm going to call it task 1 cleanup the code. That's the first thing I'm going to do. Okay, so very simple. I'll take this plastic message io.cs file. It's not a small class. I mean, it's well, there are some lines here and there. So the first thing I'm going to do is just clean up the code with ReSharper, clean it up. Here it goes. It cleans the whole thing, and I will just go and save my change. The file will be, check it out now. Let me find it. Here it goes. And what I'm going to do is just diff it with previous. And here I'm going to use Semantic as a diff tool, which is also an option, right? Well, that's an interesting thing. It's saying that all the methods involved were just moved. So there are no actual changes. If I run a text diff, regular text diff, you see there are like 28 different changes. Follow the changes, and there are really a bunch of them. But if you look at it from the semantic point of view, you see there are only moved code. You can look at it visually, then zoom it out a little bit. Okay, not that much. And you see that the methods were just, reordered, but there are no real changes. And interestingly, even the usings were sorted differently, right? So they're like crisscrossing each other. Okay, so what I'm going to do is just close the diff. And then what I'm going to do is just checking and clean up done. Very good. The funny thing here in this story is that in the meantime, there's another developer doing a bug fix. So he creates task 02 bug fix. It's just a branch, right? So like a real branch you will create in Git or Mercurial or anything. So what I'm going to do now is I'm going to find a method which is called stream read. Here we go. And I'm going to do a very simple change. So just add a comment. This is the method fixed during the bug fix. In fact, I could go and just modify some code or something, but I will just keep it as it is, right? Just save it and so on. So once I'm done with this, I will just check in again from Visual Studio. So fix is now done, hopefully. And the next thing I'm going to do is just to merge my two branches, the cleanup task with the other one. Here we go. So, okay, I'm just going to run the merge and see what happens. Okay, I process the merge. Semantic will show up. Okay, and here we are. So Semantic is telling me there are no conflicts to check because basically it was able to solve it automatically. It's just letting me know that on a real scenario, maybe I just want to launch the tool with a -a param, so the tool wouldn't even show up. It will be much faster. It wouldn't even show up because it just can calculate the result automatically without user intervention. If we go to the stream read method, okay, let me find it. Stream read. Okay, next. Okay, stream read. Here we are. Okay, we have the comment, and it's also on a different location. Let me just show it visually. Let me zoom it out. Okay, it's too much. I will just hide it and change it. And what I see here is that originally the stream read method was the fourth, but now it's just on the bottom, and it's getting the change coming from the other contributor. So what you're basically seeing is that a merge that will normally be a nightmare, and now I'm going to run it in text mode so you see the difference, is completely automatic right now using Semantic, right? So you were able to clean up the code using ReSharper and just merge it with Semantic. I'll just run it on with the external test merge tool and see what happens. Okay, if you merge it with text tool, is finding two non-automatic conflicts, as you can see here. So there are user intervention is needed, while in Semantic it was completely automatic. But more interestingly than that, the thing is that it's trying to match the stream read method with receive headers. It has nothing to do. So you won't be able to actually use the text merge tool here, not the embedded, not the built-in one. We just include not any other one, because you will have to, okay, where is this code? Just try to figure out where it is, find that the file has been completely rearranged, and try to put your your change line there, which, it's a pain, right? Okay, so we are done with the second example, and I'm going to jump into the third. I don't know if there are any questions so far.
Yeah, Pablo, we've just had one question about the trial version, actually. Is there a trial version available, and is it available to use sort of if you're behind a proxy, for example?
Sorry, you mean, sorry, I didn't understand the question. Can you repeat?
So is there a trial version of SemanticMerge available?
Yeah, sure. It is.
Okay, and the other part of the question was, is it possible to use that trial version if you're behind a proxy? So does it need to talk back to your service to authenticate or anything?
Okay, now I understand the question. Yeah, I mean, when you download Semantic, it tries to get a trial version, and it connects to our website. If you are behind a firewall or something, just send us an email and we'll send you the license. That's all. I mean, normally that's everything in a completely automatic way. But if you are behind a firewall or something, you cannot connect to the SemanticMerge.com site. So just drop us a line, and we'll send you the license.
Okay, that's great. Thank you.
Okay, so the next thing I'm going to do is another of well, this case is very funny, because this is actually the one I used when we were initially designing the tool, right? We wanted to come up with a tool able to do exactly what I'm going to do now. So let me just jump into the code and show you how it works. I'll jump to a different solution, and I'll show you the case here. What I'm going to do is basically split a class into different classes, right? So let me just show the socket class. Okay, it's a very, very simple class. It's very similar to the one I used on the first example, in the first test scenario. And basically, it's a socket class with a few methods, right? What I'm going to do is to split the class, but two developers will be doing part of the refactor on separate branches at the same time. And then we're going to see how Semantic deals with this. So let me just go there. First, I'm going to follow the same pattern I did before. So it's going to be task 001, create client socket. So I'll just switch to the branch. Here I am. And then the first thing I'm going to do is to extract a couple of methods to the client socket. In fact, what I'm going to extract are going to be the methods connect to and send. Okay, so I'll use the ReSharper here, and I'll do extract class. Okay, I'll just call the new class client socket, and one highlight here. I'm going to click keep the classes on the same source file. You might be thinking here, hey, it will be much better if you move the classes to different files. And I will say, yes. The thing is that this is not something Semantic can do today. This is actually multi-file semantic merge. I'll talk a little bit about it later on, because that's something we're working on, actually being able to track refactors across files. That's something that is not available yet, but we are on it, right? So it will be there soon. One of the reasons why it's not there yet is because it requires further integration with the version control. So since we want to keep Semantic able to work with any version control system, Git, Mercurial, whatever, we're just a little bit, thinking about every single step there. So I just created a new client socket class with the two methods. In order to make it a little bit more funny, I'm going to switch the order of the methods. I will just copy and paste, nothing fancy here to actually change the order, right? So basically just keep it as send and connect to, so they are flipped from their original location. And what I'm going to do is just check in. So client sock class created. Okay, so the first checking is there. Next thing that I'm going to do is just create a branch, task 002 server socket. And basically, I'm going to do the opposite refactor. And to make it even a little bit more interesting, okay, let's just start by moving the recv and listen methods, these two methods, to a new class. So I'll repeat what I did before. Extract class using ReSharper, not a very difficult refactor for ReSharper anyway, very trivial for ReSharper. And there's going to be server socket. Okay, here we are. So I have the server socket class. In order to make it even a little bit more interesting, I will put the server socket class on a new location. Okay, here I can also flip the method order. I'm just trying to make it as complicated as possible, right? That's all. Okay, and I'm going to do a couple of more things. I will just call this class DNS. I could have done a refactor, but I don't want the name of the file to be changed. It wouldn't be a big issue, but I'll just keep it this way. And I'm going to do something else. Remember this connect to method? Something happened to it in the first refactor. Remember that? What I'm going to do is just modify it during the server socket refactor. Okay, here we go. I go on checking. So server socket refactor, I do a checking. And then the next step, as you might guess, is just to merge from the other branch. Let's see what happens. It's not difficult from a human point of view. Just split a class into two classes. It's almost impossible from a merge tool. I mean, for a text-based merge tool. So let's merge, and let's see what SemanticMerge says. Here it is. Okay, and it's telling me that, well, first, let's just check the visual merge. It's telling me that, hey, the class has been moved in that way. You see the methods, how they have been modified. You see how the socket class was renamed to DNS in one of the contributors. And then you also see how the connect to method was modified in one of them. And it's also warning me about, that one of the methods has been moved into contributors. Okay, I basically did something. Okay, I did something wrong on the client socket. I was supposed to move a different method to the server socket class, but again, it's almost the same scenario, right? So basically, what it's telling me is that, hey, you move the send method to the client socket in one location, but to the server socket in the other one. So which one do you want to keep, right? In my case, I will just give one of them, the destination, for instance. And then if you look at the result, you see that I get the connect method with the comment made during the refactor of the server socket class, that you get the DNS the DNS class with the two methods there left, and also the server socket with the recv and the send method. Okay, what happens if you try this with a regular merge tool? That's what you get on the screen. You get 3 non-automatic merges and basically a little bit of a nightmare, right? Because the tool is trying to match things that don't have a lot. They don't have a lot to do with each other, right? So that's basically a little bit of the scenario. I did something wrong during the case because I was supposed to move the listen method into the server socket and not the send method, right? In fact, I'm going to do that just to show you what I wanted to do. I will undo the checkout here and do the merge basically. We'll close the merge window. Now we'll do something else. It's not the send method, the one I wanted on server socket, but the listen method. So just let me do that. Okay, just let me do that, and let me get the listen method. Now we'll just repeat the merge and show you. Okay, now we have like a different scenario even, right? So second checking on the server refactor. Here we go, and I'm going to repeat the merge. Now we're going to see a slightly different merge. Okay, well, it's telling me that the connect to method was moved into different locations, but again, I get now the results, right? I get the send, I get the listen, the recv, and so on, right? And then I can choose, because in my previous scenario, let me show it visually now. What I did is that the connect to method was simply moved to a different relative location on the same one and moved to a different class. I can keep what I want to do. In my case, what I want to do is just keep it to client source. So I'll keep the source to client socket, sorry. And this way I get the final setup I wanted. Send and connect to under client socket, the DNS class just with the get host by name, and the server socket with the two methods. So, well, basically that's as being like two cases in one, but I guess you get the idea of the kind of refactor it's able to merge, right? Okay, so, well, I don't know if there are any other questions. Otherwise, I will jump into the case number 3, which is going to be a divergent move. Okay, so let's go. I'll open another solution. In this case, my case number 3. Well, it will sound familiar because basically, with my first attempt to do the socket refactor class, I basically already did a divergent. What I'm going to do here is that I'm starting at the point where I basically left with the previous refactor, and then I'm going to do something slightly different. Let me just go and try. Oops, sorry. Just want to create another branch here. So create a child branch here, task 01, DNS1. The other one is going to be DNS2. Well, basically what I'm going to do here is I will move this method. So refactor and another very common operation, which is move. And in this case, I will move it into client socket. So I'm a different developer, and I will just move the get host by name method into client socket. I don't mean that the get host by name method should be under a client socket class under real circumstances, but it's good for the sake of simplicity in this example. So, okay, I have it there, and I'm going just to check in. So move the get host by name to client. Okay. Now you can guess what I'm going to do, exactly the opposite. Task 002, DNS2. So I'll move the DNS this time into the server socket. Again, ReSharper will do the job here. Just move it into server socket this time. Okay. And I'm also going to do an edit. So I'll change this method, change it while moved to the server. In fact, I'm going to do something else. Let me just show you something. I'm going to check in this, move to server sock. I'm going to switch back to my previous change. Remember, it was in client socket, and I'm going to do something different here. I'm going to also modify the method on the client sock too. Okay, now it's a much more complete example. Let me just go and checking. Second checking. Well, you will normally be putting like meaningful checking messages and so on. But okay, merge from second branch and launch SemanticMerge. And let's see how a divergent merge works. This is one of, well, that's a very interesting scenario, I will say. Well, Semantic is detecting the scenario and saying, look, something is going on here. Let me go to the visual representation. It's telling me, look, the getHostByName method has been moved to 2 different locations, and also it has been changed in the 2 different locations. That's why the C and M icons, it means moved on one location, moved in the other location, changed and changed. When you get an icon on 2 locations, you get a conflict, right? And that's basically what is shown here. C stands for change it, M for move it, and it's just telling you, hey, this happens at the same time in 2 different locations. So what it's asking right now is, okay, which one do you want to keep? Where do you want to keep the method? In client socket or in server socket? At this point, it's showing it under client socket because we are merging from the server refactor into the client refactor. So what I'm going to do is exactly the opposite, keep the source. So I'll keep it in server socket. Okay, and as you can see here, the method has been moved down. But more interestingly, it's telling me, hey, I know the method has been modified in parallel. So you can now go and merge it. And when you go and merge it, you see a traditional merge tool just to deal with the body of the method. And that's basically what I do, right? So in this case, I'll merge the 2 comments together. They're just comments, right? So one on the first line, sorry, one of this on the line number 6, the other number 8. So I merge it together. And then I go, well, view on result, and I see, hey, I get the method on the location I wanted with the body merged. And that's all about divergent merge. Again, what will happen if you do this with a regular text merge? Well, one manual conflict, which doesn't look like too much, but basically is not even trying to merge the method that has been changed on 2 different locations, right? It's just trying to deal with the only changes that were done on the same place, which is the class in the middle, DNS. Well, I guess this gives a very good understanding of how Semantic can work together with your version control system and ReSharper to actually merge, difficult or not very, day-to-day refactors. Okay, I have a few other cases, so I'll jump into them. Okay, so the next one I'm going to show is one of the latest features we added to Semantic, right? What I'm going to do is, so far, I've been just working with the structure of the class, the structure of the methods. Of course, everything I applied here to methods will work too with constructors, with properties. That will work too, right? With namespaces and classes, this kind of stuff, as soon as you are inside the same file. And now, The second thing here is that, okay, it's also interesting to highlight that the same sort of language capabilities are available for Visual Basic 2 and also for Java. But I'm focusing on C# today. We use Roslyn under the scene, which gives us a lot of power to deal with this case 4, which is what I'm going to be covering today. Well, what I'm going to do is something like what you have on screen. What if you get a change and you make some sort of code format change? Like, hey, you go and add a new param to the method. Like here, you see this 45 that is not there and was not on the base. But at the meantime, someone else changed the way in which the code was reading. Actually, this code is equivalent to this one, so there are no real changes there, but it will create a conflict on a regular tool. Let's see how Semantic deals with it. Okay, so here we go. I'm going to open the case number 4, my reformat case, and I'm going to repeat exactly the same pattern I had before. So the first thing I'm going to do is, here we go, and then I'm going to find my method, which is this one, git set error. This is code coming from git sharp. Yeah, leave git sharp actually. So I'm going to just try a couple of changes here. So, okay, let me do something. What I'm going to do is basically, I'm going to split the declaration of the method here into 2 different lines, like this. Okay, and just do a checking. It's a trivial change, I will say. Then just split into lines, and then let's go to different test scenario, task 002, well, 002, and in my task number 2, I'm going to do something like add a new param, long code, something like that. Not very difficult anyway, but what I'm going to show here, just let me do a checking. Okay, what I'm going to do here is just I'm going to merge from the other branch and see how Semantic deals with it. Well, okay, here we go. I'll run the merge. SemanticMerge will show up and tells me the merge was automatic. Well, it's telling me that. Okay, let me show you this. Is git set str. Okay, here we go. It's this method. Okay, Semantic was able to solve the conflict automatically because it's telling me, hey, just keep this one. What did it do? Well, basically what it did was the following. Let me show it visually. What it did was the following. I had by default, when you launch Semantic, it will try to get rid of changes that are only related to the format. You have a switch to avoid doing that because sometimes, I mean, it's very common that you want to keep the format changes, but if you don't, and resolving several conflicts, it's okay, or several, in some, let's say, big merges or on these sort of situations, you want to get rid of these sort of changes, right? Someone just reformatted the code, split some lines, did some cleanup on the formatting of the code, let's say, but it can create a big mess when you try to merge. And that's basically what this feature avoids. If you run this on the text merge, you see the conflict. It's not a difficult one to solve because you can immediately figure out what's going on and decide that this is just a new error code there, but it's a manual conflict. So what Semantic is doing here is, okay, just let's make it automatic, and let's save some time to the developer, and that's about it here. Okay, so this is about dealing with code format changes. This is one of the newest features we had like a month and a half ago or something like that. Once we integrated the newest code from Roslyn, because it introduced a lot of features to to be able to deal with code reformatting, formatting different sections of the code, and so on. This, in fact, this is one of the other features that is not available in Java. It's only ready there for C#. Okay, and now let's go for my final case, which is number 5, and it's a move-delete conflict. What happens when you get the following scenario? What happens if you move a method inside a class, but you try to, you move a method inside a different class, but in the meantime, someone else deletes the entire class. What happens? Okay, let's go. I'm going to open the last solution I have ready for today. I called it test format. Okay, and what I have here is, again, the same scenario. I have a very simple class, and I'll create a couple of branches. Task 01. Well, in task 01, the developer is going to do something. It's going to move this strlen method, refactor, move. It's going to move it inside the formatter, right? Sorry, inside the formatter, just one of them. Okay. Again, yeah, it's telling me it could be broken, and it could be broken because strlen was private, so I'll just make it internal. I could have done that during the move, and now the code is okay. It's a very simple case. I mean, of course, in this case is very, very, very simple. It can be done with just a few lines. No need for an extra class or anything. It's just in order to show to show the example with the last with making it simple as possible, let's say. So, okay, we have this. I'm going to check in the code. Checking methods moved. And now let's see what the other developer does in parallel. I'm going to create a branch task 002. Here we are. And then our friend here is going to do something slightly different. He said, okay, you know what? This formatter class is completely useless. So let's just clean up the code a little bit. I'm going to do it manually right now. Just adding the string there. No need for the formatter. Okay, something like that will be fine. And then I'm going to do a refactor, which is a safe delete, which of course in this case is a little bit an overhead because it's very simple, but in a regular real situation will make a lot of sense. So I'm going to check in. So class deleted, and now I'm going to run a merge. I'm going to merge from task 01. And let's see what Semantic has to say about this. And it will come with another conflict. First, there's a potential merge. Well, there's a merge actually on the main method because the main method has been changed by the two contributors. In fact, I can just diff it or see it, or let me just show you the diff. It's telling me, hey, it was modified in one of the contributors because basically I removed the, well, I added actually the formatter to use the strlen, and in the other contributor just remove that. So there's a merge there in action that I will have to solve, but there's another conflict, which is the one I wanted to show, which is the moved deleted. The strlen method was actually deleted in one of the contributors, but was moved in the other one. So what do you want to do? If you want to just delete it, you will completely remove the method. But if you want to keep it, the method will again show up. Suppose I just want to delete it. Okay, it will stay this way. I can, of course, restart the merge. I can keep the source. If I keep the source, the method, the formatter method will show up again. Here we have a small glitch with the indentations, and we have to take care of because it's not correctly indented. That's another story. The method is there. So that's something, that's the way it works. It basically detects the situation. So it's very useful if you, for instance, modify a method and then delete the entire method, even if you moved it to a different location or something like that. What will happen for text merge in this scenario? Well, you see, it's slightly more complex because there are more conflicts there. I mean, at the end of the day, it's even having issues with the way in which the braces are closed and so on, because it doesn't know about the structure, just about the text. So this was an intro to some merge cases with Semantic, and also using ReSharper to create all the cases, and then Semantic to actually merge them all. I have a few more slides to go through, but I'm open to start answering questions if there are any. Well, one of the interesting things that are present in Semantic is that sometimes people tell us, okay, but what happens if you get a merge on a method and I just change it on line 1 and you change it on line 27? Maybe there's not a conflict if you check it line by line, if you check it in a text way. But since the change is in the same method, it's okay. It's a good idea to detect the case, right? That's basically something that Semantic can do because it knows it's inside the same method. And also, you can force this resolution to be manual. Something like, okay, if you find a conflict inside the same method, even if it's automatic from a text-based merge point of view, just make it manual. So I have to review it, right? And well, these are one of the cases. Also, we take care also of the using sentences. So suppose you add two usings on different lines, exactly the same using. Okay, it will be merged automatically and stuff like that. That's not very difficult. It's not a big deal either. Very easy to detect. So, well, this is just a little bit of some numbers about some tests we ran. We tested about 15,000 repositories coming from GitHub, replying all the merges there, and we found out that normally with Semantic you have to review 97% lines of code. It's just a number there. What we found out because you basically get less conflicts as you have seen during the demo, and also we found that even that you are trying to avoid right now most of the time moving methods around, is still 23% of the conflicts what we consider semantic. I mean, something has been moved inside the class and it's hard to track for a regular merge tool. Okay, well, a little bit of the internals, basically how Semantic sees the world. And we have an API to add third-party languages. Well, it's more than an API, it's just a way to call an external parser that has to adhere to some command line rules. And well, basically from this code, what Semantic says, something like that, it just sees the structure and where each part, each method begins and ends, and it will work based on that. And then the structure is about, okay, let's parse the three files, let's create an intermediate representation of each of the files, then diff it, and then there's the merger. In fact, the merge technology we use in Semantic is heavily based on the merge technology we use in Plastic. Of course, it's not the same, it's different code, but it's basically the same concept. Plastic uses this code for directories and files, and in Semantic we use it for structures within the file. Well, some complex cases like cyclic move is something that Semantic can also detect. It's well, this is not something that happens on a daily basis, but when you start designing the whole thing, you have to pay attention to the different details. Also things like evil twins, like methods that are exactly the same. This is the first case I went through. And I just wanted to spend a minute talking a little bit about the next steps. For us, the next step is semantic multifile. In fact, the screenshot you have right now in the presentation is a real screenshot. It's been around for a while because we have a prototype already for some months. This is exactly the same socket split method refactor that we did before, but this time moving each method to a different file, as you can see with the with the container in gray, right? You see a DNS, you see a DNS, you see a client socket, you see a server socket, and you see how the methods are moved. This is the next thing we're working on. It's quite interesting because you can end up merging code. For instance, you can end up merging the method listen that has been modified on a different file and put together into their destination file. and merging the body correctly, and then putting the method on the right location. Well, and that's basically a little bit of what I had ready for today. The cases I prepared for today. So from now on, it's about questions if you have any.
When do you plan to release multi-file semantic merge?
Okay, that's a very good question. In fact, the key here is the following: when you go for multi-file, you need something pretty interesting, which is you need more collaboration for the version control. Normally, as I explained at the beginning, the version control just sends you 3 files. I mean, for each merge, it sends you 3 revisions of the file, how it was, and the 2 contributors you are merging. In order to do multi-file, we need the version control to send us all the files involved in the merge. So if you are merging 100 files, we need to get all the 100 files to actually figure out if there are refactors in the middle or something. So this is not the standard way to launch a 3-way merge tool. In the case of the open source tools, it wouldn't be that hard because basically we can replace the merge tool code of Git or Mercurial. But for the commercial tools like Perforce, like TFS, these sort of systems probably will take a little bit longer. The easiest for us, actually the example you have on the screen, is using Plastic, but our own version control system, the system we sell, our main product in fact. But with Semantic, we want to make it ready for every possible version control, so it will take a little bit longer. Our target date probably is like the last quarter of this year, something like the last part of the year, probably November or December, maybe October if we can put a little bit more resources up front.
Okay, great. The next question, what are your plans regarding multi-language projects, for example, .NET, JavaScript, CSS?
Okay, very good. Well, right now we have C#, Java, and C. We wanted to come up with C++ too, but it's starting out to be much more complex than we initially expected. We use libclang there, so we don't do the actual parsing, but still you need to take into account all the include files and so on. So going to exactly your question, we already have the JavaScript parser ready. If anyone is interested on that, just drop us a line, send us an email, and we'll just send it to you. The reason why it's not out yet is because, well, we are not 100% sure it's so useful in regular JavaScript coding as it is in C#, because you can write many different styles with JavaScript. And for other languages, well, we have been requested to add support for project files in Visual Studio, also solution files, which is not exactly the same problem, but related. And we'll also like to add Objective-C soon.
Okay. The next one, basically a great tool, but here's a scenario I'm wondering if SemanticMerge can handle. First branch, you rename a variable, pass the method WriteLine. Second branch, method is renamed to WriteLine format.
Okay, if I got it correctly, that I'm not 100% sure, and of course feel free to just send me a tweet or an email later on if you have any more questions. But going to this precise question, Semantic is not dealing with refactors at the level of variables or members or stuff like that. Just structural conflicts, right? So if you rename a member, like a field or something in your class, it won't take that into account inside the body of the methods. If that's what you're asking for, not yet. I mean, that's something we'd like to add in the future, but not yet. We are not yet that far.
Okay, we have time for a couple more here. How does SemanticMerge deal with files it does not support? For example, a solution with a lot of C# and C++ projects.
Okay, that's a good point. Well, basically, Semantic right now will only accept C#, Java, C, and Visual Basic files. For all the others, it will immediately try to launch the text-based merge tool you have configured. So it won't try at this point, it won't try to merge like a C++ file if it can't or something like that. You can always force, suppose you are using a different extension for Java files or something like that. You can force the tool to accept another extension, but then it's up to to the people setting it up to know that they are sending the right file. If it doesn't know how to do with the file because it can parse it, it will show up a message saying I cannot parse this, and will show up a button to launch the text-based merge tool.
Okay. Next question. How often does semantic merge get it wrong? Is it usually easy for a user to realize it is wrong and correct?
Well, that's a good point. Well, in my experience, it's not that usual that it simply gets it wrong, right? I mean, the biggest point you can get is that it's not able to parse a file correctly. Suppose your file is not compiling, but it's not compiling big time. I mean, something like half of the class is not finished or something like that. Then Semantic won't be able to handle that, but it will warn you immediately, right? The cases where it can get it wrong will be more about, suppose you merge something and then it puts it on the wrong location or something like that. That's not so common. Remember that one of the key points we consider while developing Semantic is that it only parses the structure of the files. I mean, it doesn't enter into the code, only for formatting changes and stuff like that in the last version. But it's not like understanding an if is an if or an else sort of or a for or something like that. It's just looking into the method structure, the property structure. So it's more difficult to end up breaking up the code.
Okay, and the last question. Do you plan multi-language discounts? For example, I get .NET version now and would want to add Java Objective-C later on.
Yeah, you mean like some sort of bundle or something like that? Yeah, that's something we have in mind. Something like release a version with all the possible languages or dividing groups or something like that. Yeah, that's something we would like to come up with. It's not difficult from a technical point of view. We just have to, do some changes in the website and the packaging or so on.
Okay, so I think the other questions that we'll have to follow up with by email. We've reached our time. So Pablo, I want to thank you for the great presentation and for joining us. We hope to have you sometime again. To everybody, there's the slide up there with information on where you can get more information on Twitter, provide us with some feedback, and on YouTube. JetBrains TV channel. We'll publish this recording probably over the next couple days and on our blog post Q&A session that we've had. And so thanks again, Pablo. Thank you, everybody, for joining us. Until next time, thank you. Have a great day, everybody. Goodbye.
Thank you. Great day.